Hello for the viewers. Today I would like to prove about Ohm's law. V equal to I multiply R. You typically follow the steps. First, defines Ohm's law. What is Ohm's law? Ohm's law. Ohm's law is V is the voltage. This is V. Battery is V. Across all conductors and components. I is current. Current. What is current? Current is the direct source from voltage through the all components and conductor. R is for the resistance of the conductor. R is resistor. This is a series circuit. For second is understands Ohm's law. Recognize that Ohm's law expresses the relationship between voltage, current, and resistance. For three is derive the formula. Ohm's law can be derived from more fundamental principles in the electric circuits, involving concepts like electric field, charge, and current density. Fourth is consider the units. Consider units is ensure that the units on each side of equation match. Voltage is measured in volt. Current is ampere. And resistance in ohms and omega. For 5 is, for the last one, I would like to provide some example, show the practical example and calculation to illustrate how Ohm's law works in different scenarios. Remember that Ohm's law is fundamental principle in electric engineering and physics, widely accepted based on experimental evidence and theoretical understanding.
Step 1. Identify components. Identify all the components in the series circuit including resistor, voltage source, and any other elements. Step 2. Understand series circuit characteristics. Understand the key characteristic of a series circuit. 1. The same current flows through each component. 2. The total resistance is the sum of individual resistance. 3. The total voltage is the sum of individual voltage. Step 3. Apply Ohm's law. Use Ohm's law to relate voltage, current, and resistance. Ohm's law is represented as V equal I C dot R, where 1. V is the voltage across a component. 2. I is the current flowing through the component. R is the resistance of the components. Step 4. Calculate total resistance. For resistors in series, the total resistance R total is the sum of individual resistance. R1 plus R2 plus Rn. Step 5. Apply Kirchhoff voltage law. Kirchhoff voltage law states that the sum of the voltage in a closed loop is 0. Apply this law to the series circuit. Step 6. Calculate total voltage. For voltage source in series, the total voltage V total is the sum of individual voltage V1 plus V2 plus Vn. Step 7. Calculate current. Use Ohm's law. I equal V total or R total to find the total current flowing through the circuit. This step will help you analyze and prove the characteristic of series circuit. Just like from current, go through wire and R1, R2, and then go to positive part of LED, and then negative part of LED, and then go to negative of source.
The equation current equal, this is the current and this is the voltage 9 volt, and the power, the formula, the equation of the power to find the power is the P equal to IV. P equal to IV represent the relationship between the power and the current flow to the resistance and the voltage of the 9 volt in the electric circuit. Let's break down the components. Power is the amount of energy consumed produced in the circuit per unit of the time. The power is measured in watts. The greater the power, the more work can be done or more energy is being transferred. The current flow, current in the electric charge in the circuit, it is measured in amperes. Current represents the rate at which charge of electron moves through the conductor. The voltage, also known as the electrical potential difference, is the force that drives electric current through a circuit. It is measured in volts. The voltage represents the energy per unit charge available in the circuit. The formula P equal IV is derived from the Ohm's law, where voltage is multiplied by current to determine the power. The IV form of the formula is rearrangement that allows you to directly calculate the power. If you know both the current and voltage, in practical terms, this equation is crucial for understanding or designing electrical system. It helps determine the power requirement of the device, the capacity of power source, and the impact of the current and voltage of the overall performance of the circuit.
Okay guys, hello. Okay, number 1. Choose a simulation tool. Select a circuit simulation tool that support DC analysis, as DC analysis is often asked to analyze of power in a steady state condition. Number 2, build the circuit. Create or model to electrical circuit using the simulation tool, included voltage source, resistance, and any other component needed. Number 3, define component value. Assign appropriate value to the component in your circuit, including voltage and resistor. Number 4, set up a DC analysis. Configure the simulation tool to perform a DC analysis, which allows you to analyze the circuit in a steady state condition. Number 5, run the simulation. Execute the simulation to obtain the result. The tool will calculate the circuit voltage and power to each component in the circuit.